Good morning, all. This is another problem in Markowitz's model. The problem on three securities. The problem here is securities D, E, F have the following characteristics with respect to expected return, standard deviation, and correlation between them. So, three securities are given D, E, and F, and return and risk values are given. That is, return is 0.08, that is nothing but 8%. It's given in decimals. If you take in percentage, then it is 8%. Same way, risk is 2%. Then security E, it is 0.15, that is 15%, and risk is 0.16, that is 16%. F security is 0.12, that is 12%, and 0.08 means 8%. So correlation coefficient is given, that is D with the relationship between various securities like DE, DF and EF. The values are given here, that is 0.4, 0.6 and dash, that is nothing is specified, means it is equals to 1. So diagonally if you see, then the relationship between the securities will be 1. So here 0.4 nothing is given, this is 0.8. Make a note here, it is a 0.8. So correlation matrix you have to prepare based on the values given. And the question here is, what is the expected return of portfolio and the risk of portfolio consisting of equal investment in each portion invested? That is equal proportion you have to take, that is 0.33, 0.33 or 0.34, that is equal investments means divided by 3. If you take in decimals, then it is 0.33, 0.33 and 0.34. So here you have to prepare the correlation matrix. So there just the relation between two securities are given. So that based on that you have to make the correlation matrix. So D, first stock with the first security, first with second and first with third. Same way second with first, second security with second security, second with third. So you have to prepare a matrix like this. So here the diagonally if you see, then this part will be is equals to 1. So this portion is equals to 1. Remaining values are given. Based on the values given, just put it. DE first security, D second security is 0.4, then DF is 0.6. Same, you have to take 0.4, it is 0.8 here. So that values you have to put for third security also. Here, by taking the formula of return on portfolio, you have to substitute the values. So formula is RP, return on portfolio, is equals to three securities we have, no? So R bar D into XD, that is nothing but return into weights of the first investment or first security, plus R bar E into XE plus R bar F into XF. That is nothing but summation. So how many securities you have, those securities should be added. Summation of R bar X or R bar that first security into weight of that first security. So likewise you have to take the number of securities should be added. So here R bar D. So what is the value of D given is it is 0.08. So 0.08 is nothing but if you take in percentage, I have told you in the while explaining the question that it is 8%. So 8 into 0.33, that is equal proportion has to be distributed. In the question it is given that you have to find out the expected return and risk of the portfolio which consists of equal investment in each. So in each security you have to take the equal portion. So that is nothing but 0.33, 0.33 and 0.34. Right. That comes to 100%. This is in decimals. That is 0.33, 0.33 and 0.34. So here substitute the values. So first investment value directly it is given, so you can take it as 8. Then second security E, it is 15, the value is 15, so 15 into 0.33 plus 12 into 0.34, that comes to 11.67 percentage. So this is the return on portfolio. Then coming to the risk on portfolio, so some sigma p, that is standard deviation p, is equals to, you have to write the formula. So this formula I have explained you in the previous lecture, that is previous class, wherein you have to find the correlation or covariance between first and second, then first and third, second and third. So that covariance if you take, then you have to put this formula in this particular manner. That is standard deviation root of x1 square into standard deviation 1 square plus x2 square into standard deviation 2 square plus x3 square into standard deviation 3 square plus 2x1 x2. First security and second security, same risk of standard deviation 1 and standard deviation 2, that is R12 correlation coefficient plus x13 first security and third security. Again you need not take third and 1 here, both are same. 1 3 is equals to 3 1. In the previous class I told you that covariance, so if you see that slide, then you will come to get that covariance 1 2 is equals to covariance 2 1. Same covariance 1 3 is equals to covariance 3 1, and covariance 2 3 is equals to covariance 3 2. So for that particular purpose what we are doing is, here we are giving the values as 1 2 first security and second one, coefficient of correlation 1 2 plus 2 x1 x3 standard deviation 1 3 R13. Okay, so 1 3 covariance of 1 3 is equals to covariance 3 1. So that's why we are not taking 3 1 here. Make a note here that it is both are same. So for that particular purpose this formula is given, plus 2 into we are taking 2, no? So 2 into x2, x3, standard deviation 2, standard deviation 3 into R23, coefficient of correlation of second and third securities. So if you substitute these values, then you are going to get it as, so you calculate all these values, substitute the values and calculate, then you will be getting the value as 7.98%. So this is risk on portfolio for 3 securities. One is a return on portfolio for 3 securities and risk on portfolio for 3 securities. So hope you have understood. If any doubts, just message me.